Hello friends, so today we will create a ball tracking system. As you can see, there is a fluctuation over the triangle. The red one, basically you can say the position after the interpolation apply, and the green one is basically the model position predicted by the you can say the model. So let's get started. Let me show you the code first. So this is a code. Now I will explain you this whole code line by line, that how we can apply the interpolation over the prediction made by the model, and how we can track the ball. So let's get started. So let's get started. This is a video in which we have to track the ball. Let me show you the video. Okay. So let's get started. The first step which we have to follow is to initialize the video and also extract the total number of frames from the video. For that purpose, you can see these are the libraries which are required: CB2, NumPy, Pandas, Ultralytics, TQDM. Okay, and the main thing is this. First thing, we have to extract the total number of frame from the video. For that, this is a code which we required. First of all, video path will be this one, model path will be this, and ball class ID. Why we have to initialize the ball class ID? Because the model which we have is used to track ball, goalkeeper, and the player. But we use this model only to track only to detect the ball, and the class ID of the ball is 0. So for that purpose, we have to initialize the ball class ID. Then this is not required right now. I will explain later why we are using this PKL. Okay. Then we have to capture the video path. We have to pass the video path here. After that, we have to count how many frames are present. For that purpose, we use here this line cb2 cb2 that cap dot get cb2.cap prop frame count. This give me the total number of frame in the video, and after that we have to convert it into format. We will get how many frame present in that particular video. The frame width and height which is decided by us, 1280 and 720. Then the second step is that we have to run the YOLO model on each frame. For every frame, detect object using YOLO means detect ball, and after that, if ball is detected, we have to store that in particular list or in dictionary, and also if not detected, we have to store those values with none. Okay, so how we have to do it? So let's get started. First of all, we have to load the model. Model is this one. Okay, we just pass the model path, and your model is ready to go. Then I will explain later that what is this thing is that, but right now, catch file. This will be the catch file. I will tell you later that why we are using this if statement here, but right now just I want to print here none, just for the purpose here. Okay. Okay, then this will be the else statement. And else statement is basically empty here, ANDed here, sorry, not empty, ANDed here. Okay, so here we first print this message running YOLO detection first time only. Okay, then cap.video capture here. Again we have to make this make the object cap here. Then we have to count the frame count, how many frames are present in that particular video. After that, according to the frame count, we have to store the values. For that purpose, we have to make the list in which we have to store the you can say ball detection coordinates values. Initially, we will fill for each frame. We will fill it with the nan value, np.nan. We will fill every value with nan for each frame. Okay, like this. We will loop over this range frame count, and every range is filled with this value mp.nan in xy format. After that, this thing is not required. Let me do it. Let me comment this part. Then I will run this for loop for the according to the frame count. Okay, according to a frame count, we will run this for loop. Then we will read each frame from the video using this cap.read. It give me result in the frame. If the frame is if the frame is not there, then result will be false. Then it means we have to store the stop the for loop. After that, we will resize the frame according to the width and height which we have, means 1280 into 720. Then we will predict. We will pass that particular frame to the model. which give me the result. Model.predict frame verbose will be false. Okay, then it give me the result. Then I will loop over the you can say loop over the result.boxes, check if any object is detected or not. If they are it means if so if the result.boxes is not none, it means the ball is detected. Ball is detected, or the player is detected, or the goalkeeper is detected. Okay, then we will loop over this. Then we have to enumerate over result of boxes dot classes, because according to class only we have to decide that whether it a particular object which is detected by the model is a ball, goalkeeper, or a player. For that purpose we have to get two things, j and class id. Then if int the class id will be the 0, it means if the class id is 0, it means ball is detected. Then if the ball is detected, if the ball is detected, we will extract the coordinates value x, y, and wh format. So for that purpose, we use this line, result dot boxes dot x, y, wh. Then pass the j. We will get the you can say coordinates values. After getting the coordinates value, we will convert that into the float, and after that we will map that coordinates value with x, y, and wh. After getting the coordinate value for each frame, ball, we will pass it to this list. Okay, one more thing, that we have already created the list here. Sorry, here we have created the list according to number of frame which we have counted, and each frame coordinates value x, y, wh value is filled with nan value. But here we replace those values with x, y, wh coordinates value in which frame the ball is detected. After that we will break that particular if statement here, stop after first ball is detected. It might be possible that the ball, it might be possible that in you can say in particular frame two ball will be detected. It might be possible, but we will means here we store only the first detection, ball detection. We will store those coordinates value only. Okay, so that's why the break statement is there. After you can say uh, let me now run it, so that I will explain you that why this for loop is required and why this pickle is I'm using here. So let me first run this. Let me save it. Now let me run it. Okay, the message will get displayed that running YOLO detection is executing, and for each frame we will detect ball, and storing of that particular coordinate value starting with this starting in this here. Okay, with using the for loop. Okay, so wait for it. See, the int object is not literable. Let me. What's the problem? Let me show. Let me see. Okay, okay. Here should be for loop. For loop I in range frame count. Frame count. This is okay. Now let me run it. Let me save it and run it again. See, running YOLO detection first time only, it's get started, but we did not get any knowledge that how much time it will take to complete getting the detection for each frame. I did not get any knowledge about it. Okay, and it's keep on running, but I did not get any knowledge about it. For that purpose only, for that purpose, to solve that problem, I use TQDM, which give me the progress bar according to the frame count, and give me the knowledge that how much time it will take to store, how much time it will take to detect the ball from the frame, and also it's taking time to store that particular in a position list. So for that purpose, we apply this TQDM to get a progress bar for the proper visualization purpose. Okay, in this only we have to pass mega TQDM function, then range of the frame count, then the message which we have to display unit frame. So this way, when I will save it and run it again, you will get a progress bar which give me the detail that how much time it will take to detect the ball from particular frame and store that in the position list. Okay, so wait for the seconds. See, now it give me the progress bar and it's saying that how much, oh, it's calculating that how much time is going it will take. So wait for it, wait for the seconds. See, now it's give me that it will take this much time. It's taking too much time for this purpose, but I think so right now my GPU is working with many things, that's why it taking this much time. Okay, so don't worry. But right now I just want to explain you that this progress bar is just for the visualization, that we will get to the knowledge that how much time it will take for that for the model to detect the ball in the frame and also store that particular in a list. Okay, so now let me stop it. But now this problem is solved, but again and again, if suppose again I will run this, now let me run it again I have to see this progress bar and wait. Again I have to wait for the model to detect ball, means at each run I have to wait for the model to detect the ball from the frame and store that in a list. Okay, at each run. So the problem, the solution of this problem is that we have to at first turn only we will save all, we will save that particular list in which the detection of the model is there in a pickle, and we will use it again, it will use that particular pickle file again in a code afterwards. So how to solve that problem is that this way, it's very simple. For that purpose only I make this if statement. Okay, see you. And this is a cache file name, means the pickle file name. There's this one. Okay, ball position pickle file. So if it open os.path.exit means is a cache file is active, means a pickle file will be exit, it will load the cache file directly, and we will open that cache file in the read mode, in read binary mode as f, and everything will be stored again in this position list. And we do not have to wait, and we don't have to wait for the model to again to detect the ball and store that in the position. It may take time, more time for it, means after using the if statement, if we just run one time and everything will be stored in the pickle, then in a second time run it will does not, we do not have to wait we do not have to wait for the model to detect ball and make the position list. We can directly jump for other step. Okay, so this way the pickle is required, and this thing is working. If the after getting the list, frame count will be length position, then we will load it from time, we will display this message again. So now let me run this code, but before that I want to show you one thing also, that we have to uncomment this code also, because for the first run only we have to save the pickle file. For that purpose only we will open catch file, okay, the path, and then we have to write in means we have to open that in a write mode, then sf, then we have to just dump a position list in the f, and we get a pickle file and save it here with that particular name, and detection save to catch. This way the after our first run we will display this message. Now let me save it and run it. It might take time to complete this. Okay, let me see how much time it will take. As you can see, it's taking too much time, so let me come back that when everything will get completed. Okay, so see, our we can say our detection is completed by the YOLO and is stored in this position list. So after that, detection saves to catch. Now in second run, if I would run this again, I do not have to wait for the my, you can say, for the model to detect everything, and for this progress bar I directly download this ball.position.pickle, and we can get it and we can move to the further process in our code. Okay, see, loading catch detection and loading from catch is completed now. So now the step which we have, second step is completed. Now perform interpolation. Now we have to perform the interpolation here. So here, till I think so till here our interpolation is there. So now let me explain you that what is happening here. For that purpose, I have to make this. I have already made this help statement. See, first suppose this is, I can say, the position list. For example, for each frame, for first frame, second frame, third frame, fourth frame, fifth frame, these are the coordinates values. And missing frame, then these are some none values, like x value is missing here and w value is missing here, partially missing. Then first of all, convert list into pandas data frame for easy processing. Same thing is happening here. Okay, so this all line is here just for the explanation purpose. So after using this line, pd.data frame position column x y w h, so this thing I get it after this, after using this line. Okay, convert list into pandas data frame for easy processing. Now I will apply the filling missing value using linear interpolation. I apply the linear interpolation here, df.interpolation method linear after to the data frame which I have created using the pandas. I have applied the linear interpolation. How it's working? Row 1 get value between row 0 and row 2. This thing, and this is the calculation. I will not go in detail here that how the calculation is going on. Okay. After that, I use df dot bfill and ffill. What is happening here? Bfill means backward fill from next valid value. Ffill fill from previous valid value. This ensure if first or last row were nan, they get fill. It might be possible that last you can say this row will be none, or last values will be none after, even after using this interpolation. Okay, even after using this interpolation. So to overcome that thing, which we use bfill and ffill. Now it might be possible that it might be possible that must be the infinite values in the list which we have created. So to replace the infinite value with nan value, we use this line df dot replace. Then infinite value will be negative and positive both. So we replace these two values with np nan, and safety step means in place with true. In place we have to replace it with means true. So this thing is used for remove the infinite value. This, if any value was accidentally infinite or in minus infinite, it becomes nan. After that, we use replace any remaining nan with 0. Even after any remaining nan with 0. Now we rename the replace the nan value with 0. So this way, at the end, I get the complete interpolation. After, first of all, let me explain again. Apply the interpolation. Fill the last row or a first column using this bfill ffill. It might be possible infinite value get generated, so remove that with nan. And at the end, replace the nan value with the 0. After that, convert to integer numpy array for drawing an image. So we convert means now here we convert the data frame into the numpy list format. Okay. So here we, after doing all things, we convert that. For that purpose, we use df.round as step into numpy. I convert everything into numpy format, your numpy array format, and I have stored that into the interpolated position list. Okay, so this all thing I have explained. That first thing means get the data frame for easy processing. Apply the interpolation. Fill the last row of first column if it is nan values. It might be possible accidentally infinite value get generated. So replace those infinite value with nan value. Replace those nan values with 0. After that, again we want a list. So for that purpose, we use df.round as type into numpy. We get a, you can say, a list, and this all process basically fill the mains like this. Like it might be possible in second frame, no ball is detected by the model. In third frame, means this thing is not get happen, but it might be possible that second frame, no ball is detected. So after using all this, I get a proper detail, like you say, detail, or you can say interpolation. After using the interpolation, I easily fill that frame coordinates value using the interpolation. So this way we apply the interpolation, and after interpolation is complete, we print this message Before apply the interpolation, you print this message performing interpolation. So now everything is getting completed. Our each frame ball detection we get. Now we have to visualize that. Everything we have to visualize according to the interpolation. So let's get started. Okay, so this is the last step which we just, it's very easy that we just want to visualize according to the list which we had. So first of all, we read the means video capture, we use video path, we will get the cap. Okay, now frame id will be 0. Track means track correct frame index. Now we want to get the fps of the frame of the video. For that purpose, use cv2.capprof fps gap.get, we get the fps. Then we convert fps into delay as per frame. So means has millisecond per frame. For that purpose, we divide 1000 by fps, we get the delay here. Okay, then loop through video from frame again. Now we loop over the frame according to the frame which we have. Means we have to read the frame one by one. For that purpose, we use cap.read. It give me it return two things, ret and frame. Frame is just, you know what is this. Ret is a result, means if suppose no frame will be there, return result is a return ret value will be false. If it is false, mean we have to break the loop, means video is get end. Now we have to resize it to 1280 Then we have to, according to the frame, means according to the frame only, we have to extract the coordinates values. So this for that purpose only we use this frame idx, which is initially it will be 0. Okay, that's why in 0 index value I will have to extract x by wh. After that, if not amped.isnan position frame idx 0. Okay, so here we decide that the you can say the color of the triangle will be red or green. Green means the detection is done by the YOLO. Otherwise, the detection is done by the you can say detection is done after interpolation. So how it decides it? For that purpose, we do use this thing. You already know that the see, first of all, let me explain this. First of all, here we are using the list position. Okay, and here position list is basically you basically is updated by the YOLO detection, and we already filled the means position list with the nan value according to the frame count, according to the frame. For if suppose if in a second frame is suppose a second frame, the detection is not done, it means that line will be none. Every value x by wh will be none. So that only if the position frame idx 0 means x coordinate value will be none, it means that in that particular frame, YOLO has not detected the ball. It means that color will it means that that particular triangle color will be red. Otherwise, if it is not none, value will be there. It means that particular it means that ball triangle will be the triangle will be that color will be green, and it is detected by the YOLO. I hope it's clear that how it's working, how why we're using this position and why we are using this insnan, and okay, why we are using this. So it might be, I don't get confused. So after that, we just want to get the points coordinates value to fill that particular means to display that triangle. We have to use this fill poly, and for that purpose we require the triangle coordinates values. For that purpose, use np.array, and this coordinates value means bottom point, top right and top left. This is the calculations done by me. Okay, according to the coordinates value which we get. For that has according to that only I have calculated. Okay, after getting the points, fill poly frame points, then the color which we want to display, whether it is a green or yellow, red. Then for polylines, cv2 draw border around triangle. You already know that we are drawing the, let me open the video where it is. See here, see here, this triangle, in this triangle there is a boundary with a black color. Okay, so to display that boundary with a black color, we use this frame points true, and this is the color which we want to display, and this is the thickness. Okay, and it is the coordinates value which is calculated by me. Okay, then we have to update the id, because for particular frame we have to get a coordinates value. This thing we have to see that that a particular detection is made by the model or not. For that only frame id we have to update it, After that, we just have to show the frame. And if we just want, we want to, I also want to know, I want to see that as soon as I press Q, everything will should be vanished. For that purpose, key is equal to cv2.wait key done delay and this thing. Then as soon as I press Q, everything will get vanished. While loop will be stopped, and video will be get end. We have to now release capital release the video recorder, video resource, and also we have to restore all the video, destroy all the windows. So this thing is done. Everything means third step is completed. First, extract the frame count. Second, YOLO detection and store everything detection in a position. First of all, make the position list with NaN values according to frame count. Third, apply the interpolation. Fourth, after applying the interpolation, see the result or visualize the thing. Now let me save it and run it. This is the final result which you want to display. Okay. It directly load this ball dot position because we have to already run this first time only. It's take time. See. First of all, now let me show you the result. See, load catch, loaded from catch it, performing interpolation, interpolation completed. Then this is a visualization. See result. Okay, it's working very well. Somewhere it's missing, but it's working very well with interpolation. You can use any other method other than interpolation. It's up to you. Okay. So if you gain something from my video, any knowledge related to ball tracking, so please like, share, and subscribe my channel. Thanks to all.